Let's take a look at Project 4 for Algebra 2B. This is Part 3. It corresponds to Lesson 19. Let's get started. So we are looking at Digits Game. Again, if you're not remembering, if you're not familiar with the context of Digits Game and Polly's Game, please go back and just review earlier videos or review the earlier sections of your project so that you're up to speed. So looking at Digits Game, he wants to know the probability of the following events happening on two separate spins. And remember, he had a spinner that had 12 equal sections. So spinning a praline wafer and spinning an oven-baked apple and lavender calzone. So we're not dealing with the actual probabilities. We're representing the probability of spinning a praline wafer as A. The other event is event B. And we're just saying which formula would Digit use to find this probability. So if you're not sure, one thing I would do is, first of all, look up definitions because your definitions tell you what formulas to use. For example, independent events, compound events, complementary events, all that stuff will help inform you of what you're looking for. I would also apply maybe a simpler example to help you kind of figure out your formulas. And here's what I mean by that. Let's do a different example. Let's say I wanted to know the probability of first, let's do a coin toss example. Let's say I wanted to first know the probability of getting tails on a coin flip. That'll be event A, and then on the next flip, getting tails again. And I want to know the probability of event A and then event B happening. So if I plug in, now I know that for each of these, the probability of getting tails is 1/2, right? Getting tails the first time is not going to affect whether or not I get tails the second time. So the probability of each of these events, event A is 1/2. The probability of event B, flipping tails on a fair coin, is still 1/2. But I'm saying, what's the probability of getting A and B? And that's the first thing you'll have to figure out is the symbology over here. So does that symbol mean and or? Okay, so you have to figure out, first of all, which one of these symbols are you trying to grab? And I'm not going to tell you the answer there. You'll have to look it up. Remember, one of these means union and the other means intersection. So if I'm trying to figure out the probability of both of these events happening, which one will you be looking at? Now on the other side of it, so that's just the setup, but on the other side, the actual sort of formula part of it, let's take a look. So for example, probability of A times probability of B. That would be like in my example saying 1/2 times 1/2, which is equal to 1/4. So I'm saying that there's a 1 in 4 chance that in 2 coin tosses you would get tail 2 times in a row. All right? And the reason that I'm doing this, using this example, is just to help you kind of figure out, well, aside from just looking at the definition and blindly applying the formulas, right, just use your reasoning and use your common sense. Does that make sense that that would happen? Looking at the next one, probability of A is 1/2 times the probability of B given A would still be 1/2, right? Probability of A, 1/2, plus probability of B, 1/2. Notice that in this case, probability of A is 1/2, probability of B is 1/2. 1/2 plus 1/2 equals 1, right? So does it make sense that the probability of getting tails 2 times in a row is 100%? Does that seem like the right formula for that, right? So again, just go through these individually. This is for dependent events, okay? So again, this is the formula for dependent events. Do you think that these 2 events happening on 2 separate spins are going to be dependent events? Does it make sense to use this formula? I've already kind of ruled out the fact that this formula doesn't really make sense, does it? There's not a 100% chance that if I flip a coin twice in a row, I'm going to get tails both times, right? So that's probably not the right one, and I'll leave it to you to kind of figure out the rest. So which one of these makes sense of the 3 that you have left? And again, aside from applying common sense, go look at the definitions. Figure out, is this a dependent or independent event, compound event, complementary event, look at each one of the formulas for these to help you figure it out. Next, what is the probability of spinning praline wafer and then spinning oven-baked apple and lavender calzones on the next spin? All right, praline wafer, if I can find it, here it is, it's labeled on one section. So the probability of the praline wafer is one section out of 12. So there's a 1 in 12 chance of getting that. So they want to say, what's the probability of getting the wafer and then the calzone, which is here. So the probability of C, the calzone, is 3 out of 12. And I'm not going to simplify that just to keep my actually, maybe I will. Maybe it will make it easier. So I am going to simplify it. So to simplify 3 over 12, so that's 1 over 4. Okay, so I have to figure out the right setup for these. So I've got probability of W and I've got probability of C. Probability of W is 1 over 12, probability of C is 1/4. And I need to combine these. Okay, I want to know what's the probability of spinning this one and then on a second spin spinning that one. So what's the probability that this occurs and then that occurs? You're going to use your formula from the previous slide and fill in these probabilities for A and B. So maybe you could assign, it doesn't matter, but you could assign maybe this one to be event A and this one to be event B. Again, go back to the last slide and fill in your probabilities. Oops, I just caught a typo, I think. No, I didn't. 3/12, that's right. Okay, so again, now that I have these probabilities figured out, I have to figure out what's the right way to combine them. Am I multiplying these together? Am I dividing them? Am I adding them? Am I subtracting them? Am I doing something else to them? Use your answer from the previous slide to figure out this probability and fill in these probabilities for event A and event B. Now we're going to think about Polly's game of drawing a card from a standard deck of 52 playing cards. It says she will randomly draw 2 cards. After she draws the first card, she will not put it back in the deck before drawing the second. So Polly wants to determine the probability of selecting praline wafer and then selecting pressure cooked mushroom and garlic chicken. So in this case, A is going to be that wafer, B is going to be the chicken, and we want to know what's the probability of drawing a card that allows her to select the praline, and then without putting that card back, she draws the second one and she ends up with the chicken. So what formula should she use? So again, ask yourself, are these events independent? Does event A in any way affect event B? Are they dependent? If they're dependent, that means that the probability of A affects the probability of B happening after it. Or are they some other classification? Are they, again, is there some sort of mutually exclusive thing going on? Are they complementary? Okay. So which one of these will make sense? And again, look up the definition. Once you decide whether these events are independent, dependent, complementary, or some other thing, look up the definitions of each of these, and the definitions will provide the formula for you. So once you classify what kind of situation you have going on, you can look up the definition. And in fact, looking up these definitions to begin with will probably help classify it. But again, once you classify, the definitions will tell you what formula goes along with them. Okay? And once you know that, you'll be able to select the correct answer. So, just like before, once you have your formula, you're going to use your formula from the last slide to answer this question. So, what is the actual probability of selecting praline wafer and then selecting pressure cooked mushroom and garlic chicken? So, praline wafer is somewhere, where is it? I'm having trouble. Oh, here it is. If the card is a diamond. So, the probability of the wafer is if it's a diamond, which is a 1 in 4 chance of getting a diamond, right? Or I could think of it as a 13 in 52 chance. Next, the probability of getting chicken, which is right here, is if the card is red. If the card is red. So, you have to ask yourself when setting this one up, first of all, assuming that this one happened, assuming that we've already drawn our diamond, how does that affect the probability of this one? So notice that when I set this up, my denominator is going to be 51, okay, because I did not put that card back in the deck, did I? So I only have 51 cards left. Now, also remember that normally that there are 26 red cards, right? 26 red cards. But we drew a diamond on the last turn, right? That's what happened here. We drew a diamond. So if I drew a diamond, there are now only 25 red cards left. So my first probability is 13 out of 52, right? I could have drawn any one of the 13 diamonds in my 52 card deck. Then I kept that card. There are now only 25 red cards left in the deck of 51 cards total. So that's my probability of getting the garlic chicken. Now again, it's up to you to figure out how to combine these based on the formula that you selected in the last slide. So explain in detail how you determine your formulas that you selected. This one should be pretty straightforward. You're just explaining your reasoning. So talk about what you saw in the context that let you know what kind of events you were looking at and how they were connected. So again, thinking about, are they independent or are they dependent in particular? And then how you use that definition, how that definition led you to the formula that you selected. I want to see probably about 4 complete sentences here. Again, write clearly and use correct grammar and mathematical language where appropriate.